Hello, 8th graders. This is the instructional video for how to start your hypothesis and prediction sections of the science fair. The first thing that you need to know, it's really important, you should not be starting this section unless you have an approved idea. If you don't have an approved idea, you may end up doing some work that you might have to repeat if you have to switch your idea afterwards. In order to figure out if your idea is approved, you should go to the idea submission document and check the last rubric that was sent to you. If you have the section grayed in that says ideas approved, then you can move forward to this section. There's also these are the instructions that you're looking at here. This assignment will be completed in Google Classroom. It's going to look like this in Google Classroom. You are watching this video link, so I imagine you were able to find this video so far so good. As you follow along with me on this instruction sheet, please be sure to highlight and underline as you go. First thing that you should do is go and check the timeline and make sure that you have the deadline for these assignments put into your planner already. These two assignments should be able to be completed in just a few minutes if you have an approved idea. The hypothesis and procedure are not very long. So let's get into it. First thing that you should know is that so far all of your sections should have the same kind of format and spacing and text size as your other sections. So if you need to go back and check on your research review and SOP and make sure that everything is matching, that would not be a bad idea. All right, let's get into the details. First thing to realize is that a hypothesis is not the same as a prediction. A hypothesis is something that's going to explain your observations, or it's a testable idea for what you've observed in the world. So we've done a few of these in class during our Unit 1 section. You should still have the notes from that, so if you're a little bit confused about how to make a hypothesis, that would be a good thing to go back and look at. But the big three things to avoid are anything that's based on an opinion, so like, I think that tests are bad, or I think this, or you think that, or anything that has the word should in it is usually an opinion based and is not a hypothesis, because you can't test if that's true or not. The next thing is anything supernatural. You should probably not have an approved idea if this is the direction you're heading. So just in case, maybe read through that just to be sure. And the last one is anything that's unethical. So like, well, the example here is humans need a functioning brainstem in order to survive. If you were going to test this hypothesis right here, you would need to remove people's brainstems, which would not be ethical and is not a good hypothesis, therefore. There are a couple of examples here about ants that are also going to go forward in my prediction video as well. So suppose you had some ants and you wanted to figure out why the ants are attracted to your picnics. And your first idea is, well, maybe they're attracted to some odors. So your hypothesis might be this: ants are attracted to some fruit odors over other fruit odors. This is a good hypothesis because it's an explanation for your observations. You've noticed that ants are attracted to some things on your picnic. It's testable. I can get some ants, put some fruit out, see what they're attracted to. And it's also falsifiable. If I get data that shows that, well, it doesn't really matter which fruit they're attracted to, then I would falsify that they are attracted to some over others. So it's a good hypothesis because it meets those requirements. Before you turn in your hypothesis, make sure that you are looking at the rubric. The biggest mistake that I usually see is people writing it as a prediction. You should not have anything that predicts anything in your hypothesis. It's a simple one-sentence statement, nice and short and sweet. Let's get into the prediction. For the prediction, it should be an explanation of what you think is going to happen when you test your hypothesis. The first bullet here says it can be in line with your hypothesis. So if you remember back to the ants one, my hypothesis from the ants was ants are attracted to some fruit odors over other fruit odors. I could predict that ants are going to be attracted to cherries, or ants are going to be attracted to these couple of fruits. Like that would be a prediction that would be in line with this hypothesis. You can also have a hypothesis that is a prediction that is counter to your hypothesis. That would be like ants. You think this is going to be disproved. I don't think that ants are going to be attracted to any specific fruit. Either way, you're making a prediction in line with your hypothesis or counter to it, but one or the other. You do need to have a because statement inside of your hypothesis, and it should be based on the research that you've done. So when I read your prediction, it should be pretty clear that you have learned something about your topic, and you're basing your prediction on what you have already learned and read about. Your prediction should be specific to the method. So If I'm reading your prediction and you're like, yeah, ants are going to be attracted to one more than the other, that doesn't tell me anything about what you're planning to do. I'll be more clear on that when we get down to the examples. And often predictions are in an if, then, because format, but you don't have to do that. And so be sure that you look at the examples so that you can see what I mean. So let's get to those. I've got 3 examples here. The first 2 don't follow the usual format, and the third one does, but they're all perfectly fine examples of a prediction. So a lot of them often will start off with, it is predicted that, and then there's a because statement after your prediction. That's the kind of format I'm looking for. The third kind is either the usual if-then that you would usually have seen in 6th and 7th grade, but it still has a because statement at the end as well. So let's get into what makes these good. The first one is good because it's specific about the actual procedure that they're going to do. So it says it's predicted that the number of ants will be attracted to cherry, orange, and lemon scents equally. So this shows me that they're going to be testing these 3 scents. And then it says because markers are made of chemicals that only smell like fruit. So they're going to be clearly testing this with markers. I can see how this is specific to what they're going to actually be doing. And it's telling me exactly what they think is going to happen when they test ants attracted to marker scents. Another way to think of it is that this one's the exact same format, but this is the opposite. Like they predict that they're going to be attracted to the cherry scented markers more than others. They've picked a specific scent that they think is going to win out. The last one is if then. If you decide to go with this format, totally good. The first part, the if part, is talking about your independent variable. So if ants are given an opportunity to travel to different markers, that's going to be my IV, the 5 different markers. Then more ants will be attracted to the cherry scented. This is the DV. They think that there are going to be a number of ants attracted to a particular marker. And they still have a because statement that shows me that they've done research. The bad examples are probably sometimes the best way to figure out how to do this because you're seeing what not to do. So here's an example. This is a bad example. It is predicted that the ants will be like the odor of higher sugar-containing fruits than the odor of other fruits. So first of all, it's got some bad grammar in there, but they're showing me that they're going to like the odor of higher sugar-containing fruits than the odor of others. So how are they going to measure this if they like something? In the previous examples, we're saying the number of ants are going to be attracted. That's something we can measure. How much an ant likes something is not something that can be measured. It's also not so good because it's not very specific. They're not showing me how they're going to measure again. And this doesn't show me anything about their research. So there's no because statement at all. The next one that says that ants like cherries the best. So this one is not testing what ants like. Again, same issue. The second issue is this does not connect to the experiment. So if I say ants like cherries the best, that doesn't tell me anything about how you plan to do this or what measurements you plan on doing. And this one's also missing any because statement. As with all other sections, please make sure that you check the rubric before turning this in. Good luck.